you see that we're concentrating on the den and study. Over the entryway, we have a triple 2x10. So we have 3 2x10s that are acting as a beam. Again, that's something that should bring your attention to it to realize that there's a load being carried there. And you want to make sure that the carpenter actually has 2x10s and actually has 3 of them. I've often gone on inspections where the contractor eliminates an LVL and just uses conventional lumber, or where they're calling out a triple or a double 2x10, 2x12, and the contractor eliminates one of them. And often I'll hear that the architect is overbuilding it. And what we do in the field is we say, hey, we're fine with that as long as you give us a letter that's stamped and signed with the architect's seal that he's okaying what you're doing here, this change that you're making. So if we continue up on this plan, you see that we have the 3.5 by 5.25 PSLs called out, and there's 3 locations where they're called out. Now, again, when you see something like this, you know that from the upper level, from the second floor, and also at the roof line, starting at the roof level, that there's some type of a load that's being carried down. So you always want to look at these load points and make sure, starting at the top of the structure, that that load is being carried down ultimately to the foundation footing level. Okay, then you can see that they're calling for a double LVL. So we have an 1 3/4 by 11 7/8 LVL that's carrying a load over an opening. So you have a wide opening. You have a 6 by 6 by opening going into the den study. And in that entranceway, you have this LVL. Because of that opening, and you took that section of wall out, so to speak, the architect has done the calculations and decided that an LVL is important to be installed in that location. And then if you look at the joists, the floor joist above will be 2x10 joists, and those are going to be 16 on center. Now back to that connection that the architect talked about. He wants a top mount connection over the LVL header. He's talking about a connection point that's going to be secured to the top of the header that's going to be holding that triple 2x10. Now, just to explain a little bit more about what is an LVL, what's a PSL. So I have this slide up here. This is showing you an LVL beam that's posted by about 6 2x4s. So that's the post carrying the weight of that beam. Whatever load is being placed on that beam is being carried down to the foundation and ultimately the footing of this building or this structure. And then you see you have joists hangered into this LVL. So this LVL is carrying quite a load. You can see that it has 2 floor sections that's being carried by it. And again, the architect decided that this was the size LVL required in order to carry the loads that are being placed on it. And ultimately, the post was the right post, the architect determined, to carry it to the footing foundation level. So an LVL is an engineered beam. A PSL is going to be something that's found more in posting. So the LVL is glued together for spans. The PSL is strands aligned under pressure, and it's used typically for columns. So you're going to see PSLs used mostly for columns. And in this slide, this would be an example of a PSL post carrying a truss girder, which that path would continue down all the way to the footing and foundation level.